Alrighty, good morning. My daughter woke up sick with a fever today, so that's why I'm not there today. I have not had the baby Gwen yet, so I will be there tomorrow, hopefully, as long as my daughter's feeling better. All right, so today we're going into Unit 6, Lesson 3, Multiplying Powers. This is the start of our exponent laws. Okay, so make sure you do your bell work question and your warm-up question. Those are still 2 points per day. Now, if you need to split your screen, so you have the video on one side and then amplify on the other side. Okay. So here we have our first activity. Okay, we're going to be sorting out some cards here. Now, what they kind of don't go into and talking about is they don't really give you the rules first. They just want to see if you can get them figured out. So remember, exponents is about how many times you're multiplying that number. So like here's with the exponent, and then here I have 10 fives. So I would put those together. All right, because that's 10 to the 5th power. Okay. So then if I look at 10 to the 7th power. Now remember, if you can't see everything, try zooming out with your control negative. Sometimes they're sitting down here below. And I control positive to go back up. Okay, so these are the ones that we need to match with some of the others. So I like to keep my stuff kind of sorted nicely. Then I can see everything I'm working with here. We might have some leftovers, it looks like. All right, so then which one of these has 7 tens? All right, so if I want to do this one next, well, here we have 4 and 3, so that makes 7. So that would be 10 to the 7th power. All right, and then 10 to the 6th power. So we want one that has 6 tens. Well, we have 3 and 3, so we can put those together. All right, so we got those. Now we got 8 and 9. So which one has 8 and which one has 9 out of here? So this one is 1, 2, 3, 4, 5. 5 and 3 makes 8. And then our 9. And then I'm going to show you what we're going to do with these other things over here. Okay. This would be our 9. Those were the easy parts. These are what these expressions are. Okay. So this one where we had 10 to the 3rd power times 10 to the 3rd power. That goes as well with that expression now. So hopefully that makes sense. Here we have 2 tens times 3 tens. So that'd be 10 squared times 10 to the 3rd power. So now we're going to have 3 things in each of these. And we're just putting them with how many we have. So this one has 4 and 3. So that's 10 to the 4th power times 10 to the 3rd power. Together, that makes 10 to the 7th power. Okay. And then let's see, here we have 2 and 7 to make 9. And 3 and 5 to make 8. So what our rule is, when you are multiplying powers that have the same base, 10 is the base, 8 is my exponent, okay? If they have the same base but different exponents, you just add your exponents. So 3 plus 5 make 8. So that's why that's 10 to the 8th power. It's kind of like you're simplifying how many exponents you actually have. Okay, so what patterns do we notice? Exponents are added. Okay, so now we have activity 2. Okay, right, so to a single power, well, how would we write this? So this is, you're going to have to use your little handy dandy special little calculator, and you're going to use the AB button. A is your base, B is your exponent. So we have 2 to the, well, 3 plus 5 is 8. All right. Now, if there is no exponent, we just leave it as 1. So here we have 7 times. We're going to put a 3. 1, 2, 3, 4, 5, 6, and 7. End parentheses. And then times 1 lonely 3 on the outside. So that would make your 2 to the 8th power, or not 2, my bad. It's not even 8 o'clock yet. I'm not quite fully awake. 3 to the 8th power. We're not even solving what these are. Now here they want us to go backwards. So we have 2 things we're doing here. We have a fraction of 1/5. That's our base. And we have it twice. The first time we have it 1, 2, 3, 4, 5, 6 times. So our exponent is 6. Okay. And then, let's see if they'll let me copy and paste. Copy it. Oops. I can get rid of this little square. There we go. Nope. I didn't do it. There we go. 2 times for that one. Okay. I know it might take you a moment if you need to pause the video to use your calculator the right way. And of course, how does it look as a variable? So we have A times A times A. There's 3 of those. Times, and you notice how we can put them in parentheses to kind of like group them so then you can tell what it is. Now we're going to put 4 A's. A times A times A times A. Well, how many A's do we have in total now? 7. So we're going to put A to the 7th power. If you need to pause and get caught up, go ahead. What patterns do we notice? We have the same bases, exponents added. That's like your very generic way of putting it. All right, our last activity, activity 3. We're going to skip the are you ready for more? All right, so challenge 1. 2 expressions are equivalent and 1 is not. The expression that is not, choose which one is not equivalent. Then explain to your partner why it is not. So if you want to pause the video, see if you can do this one on your own. Okay, how do you change the expression so that it will have the same? So first we got to identify which one is different. Okay, so there are 3 different challenges we're going to do. This first one, I would choose this because this is addition, whereas these were multiplication. So if we changed it to be 3 times 3, like multiplication, so change addition into multiplication. Okay, then they would be 3 to the 5th power. All right, let's go to challenge number 2. Which one do you think does not belong? Now this one, we haven't really talked about the rules that really go with it. Okay, once we get farther down the line, the one that does not belong is this one, because they're not really to the third power. They're just times 3. Whereas this is 5 to the third power and this is 4 to the third power. Then what you would do is take 5 times 4 and keep your third power. So that's why those two would be the same. So what we would need to change here is change from multiplication to exponents. And you could literally type it to look like 5 to the third power times 4 to the third power. Okay. That would make it equivalent to the other two. And our last one. Which one does not belong? Give you a moment. Well, our base is a half. And this one, our exponent is a half. So that is why the middle one does not belong. It should be as an exponent of a half to the 6th power. And then, boop. Right? Did it put it right? I don't think it did it right. There we go. It had to be up a little bit higher. Now, this would be the same thing because we know 1 times 1 times 1 times 1 times 1 times 1 is still going to be 1. The only thing that's going to change is the 2. So that's why this one is still equivalent to the other one. Alrighty, so you have your summary. Kind of goes over whatever you should have the same base. You add your exponents, though our base cannot be 0. Okay, that is the only time that rule is not allowed. All right, so then here's your example showing you 4 to the third times 4 to the 8th. You just take your exponents and add them to get 4 to the 11th. Alrighty, so you're going to do problems 1 through 6. Some of them are multiple. So this one's practicing what we just did. So is this slide. Yes, we have negatives too. And your negatives have to be inside the parentheses. There is a difference, and I'll explain more of that tomorrow when I'm back. All right, so then you have word problem number 2. All right. So you need to find a rectangular pool with 1,000 feet long, 1,000 feet wide, and 10 feet deep. Okay. Find your powers of 10. How many times would you multiply 10 to get 1,000? How many times would you multiply to get 100? And 10. That's all you're doing right there. Okay. And then you use that for this slide, for the rest of problem 2, to find your volume. Remember, cubes or prisms are length times width times height. Okay, and then put your answer as a power of 10. Problem 3. What could you multiply here to get 2 to the 14th? So you're kind of finding your missing part to make the expression true. Problem 4 is coming back to proportionality. Okay, so this is one of your shapes, and then you have your prime shape, the new one. It was a dilation. So BC, your hypotenuse, is now half the size of what it was. So now find what your other sides are going to be. Problem 5, you're graphing their 2 situations, selecting who won more, and explain your thinking. And then number 6, your last one, is evaluating this following expression. Okay, if you have any questions, you can always feel free to email me. Okay. Otherwise, I will see you tomorrow. Make sure you complete all your work and you're on task. Thank you.